Furthermore, the battery dominant power system model also exercise two step load transient. The first step load is a 3 amp transient step load directly across the total series input voltage V1. So in this case, the 3 amp step load step from 0 amp to 3 amp, causing the battery charge current response to reduce the charge current from 31.7 amp to 21.1 amp to accommodate for the power increase in the high voltage load across the total system serial input voltage V1. That doesn't affect the total sourcing power because in the maximum power tracking mode, the total sourcing power remains constant since the sourcing parameter still the same. As a result, the transient voltage of the total series connected input voltage V1 still remain the same steady state, even though they have some slight transient, but it will recover to the same peak power voltage, which is about 78 volts total. In other words, on the average, it is about 3 power source, 78 divided by 3, which is about 26 volts per power source. Another step load simulation which is performed in the different section of circuit simulation is the 600 watt step load across the battery bus. This particular 600 watt step load causing the battery to sourcing the current between 1.47 amp to 31.72 amp. This battery current from 31.7 to 1.4 amp happen because of the 600 watt step load. When the total system load across the battery bus increased 60 watt, the charging current of the battery had to reduce simply because most of the power had to go into the load instead of going to the battery. By all means, the total serial input voltage still remains 78 volts. Despite some transient in the short term, it is able to restore back to 78 volts, the optimum system series input voltage. This showing that the maximum power tracking is robust and able to tolerate the load turbulency. For this system simulation, all power source have open circuit voltage of 50 volts with different sourcing impedance. Now moving to the regulated bus power system simulation. For the regulated bus, they have a bus output called bus out that regulates to 110 volts. During this bus voltage regulation, the commanding step load current between 0 and 400 watts across the serial input voltage V1 happen to step the current between 0 and 5 amps. This doesn't affect the MPT operation. The maximum power tracking still engaged with some slight transient, but eventually restore back to the same total sourcing voltage of 78 volts. Even though the step load may be restored back to 0 amp, while the battery increase the current to whatever the system can offer, 26.3 amp, some transient of the sourcing voltage may exist, but eventually it restores back to 78 volts, which is the system optimum power voltage. This causing the distributed voltage across each power source to be around 26 volts per power source. During that transient, the bus out voltage still regulates solidly without noticeable transient. This slide also shows the detailed zoom in of the system response obtained from the regulated bus power system. The system's serial sourcing voltage V1 is well tracked at its optimum level to maintain high power tracking efficiency. The average voltage across these sourcing voltage is about 78 volts, with about 1 volt peak-to-peak ripple superimposed on it. This ripple is of the same low frequency and have a sinusoidal wave shape. This demonstrates that at the peak power tracking operation or MPT, this low frequency ripple is expected, and this ripple also propagates into the bus output voltage as well. However, this propagation of this ripple is quite insignificant because the regulated bus have the high gain and able to attenuate this ripple to a value that becomes acceptable. During the time that the battery charge current response have to adjust naturally to be compatible with the step load that step between 5.2 amp to 1.1 amp. This step load current appear across certain load, particularly across the bus out voltage. Even though the step load have significant transient, the bus out voltage still have very negligible bus voltage transient. A little brief here and a little brief here. Basically, the bus out voltage still very steeply regulated, and the maximum power tracking continue its operation without being significantly perturbed or disturbed in its operation. This demonstrates that the maximum power tracking operates effectively. To fully appreciate the Siri connected power architecture applicable to Siri connected power sources, it is appropriate to point out potential candidate applications of these two power architecture with respect to Siri connected power source. In one area of modern satellite power systems, the battery dominated bus architecture or regulated bus architecture, both are applicable. Furthermore, in particular area of electric propulsion such as Hall thruster electric propulsion that require high voltage to feed this particular propulsion system. Another area is in commercial and residential grid-tied solar power system. The same power system architecture of Siri connected power source also applicable to grid-tied inverter application. In this application, the grid-tied inverter actively regulates the DC bus input voltage across this power source to track the group peak power voltage of the Siri connected solar array panels. The third area of application is in efficient high voltage DC power transmission. By stacking of DC power source in series to provide higher voltage before transmission over a long distance. Part of DC substations can be created to boost DC voltage back to normal to account for distributed loss in the transmission cables. Finally, the fourth area of application would be solar battery charger for carports or parking lots, which it help improve the system power conversion efficiency. In conclusion, optimum power tracking with uniform voltage distribution among series connected power sources had been validated through computer simulation for both power architectures, battery dominated bus and regulated voltage bus. With only one MPT controller, nearly ideal peak power is achievable with reduced component counts despite different peak power levels of individual power sources. Thank you for your attention.